Hello and good afternoon if you're on the East Coast. And welcome to another episode of Phil Tries to Solve Coding Puzzles and katas and just other programming things. So today we're starting a new coding puzzle from Code and Game. It is called The Last Crusade, Episode 1. Let me just turn the volume a little bit for the music. Turn it down just a little bit. Okay. All right, so what are we dealing with here? We'll learn about conditions, apparently. Okay. This puzzle makes you use an associative array. What is that? Yeah, we're doing this in TypeScript, JavaScript. We don't have a data structure called an associative array. Hash table, okay. Well, that's probably closer to a map, right? What we call a map in JavaScript. Multi-dimensional array, we're getting used to using that. I am anyways. Two-dimensional array. Even created a little custom class for it. What foresight I have. So let's see if we get to use that. I don't know. We'll see. Depends what we're supposed to do with that. Okay, so associative array that make a link between arbitrary types and directions. You also need to store some values in a 2D array. Okay. The goal of this puzzle is to predict, oh, look at that, animation. Cool. Okay, the goal of this puzzle is to predict the path that a character will take in a labyrinth according to the topology of the rooms. The resolution of this exercise intensively focuses on the correct usage of associative arrays. If you can manage them correctly and create the right associations, your final code could be quite short. Yeah, unlikely. I rarely write short code, and one of the reasons for that is that, well, I mean, when I compare my solutions to other people's solutions on Code and Game, I try to be very explicit in my code, try to make it easy to read, and understand what's going on. So sometimes it ends up being longer than it could if it was very, succinct and very, what's the word? Well, I can't think about it, but, short variable names and stuff like that. All right, so the goal of this puzzle is to predict the path that a character will take. Didn't I just read that? I guess I did. Okay, keep going. Story. Indiana is trapped in a tunnel. Help him escape. In this first level, you just have to get familiar with how the tunnel works. Your goal is simply to predict Indiana movements within this tunnel. Okay, cool. All right, let's take a look at the rules. Is this supposed to be gray? I guess so. Okay. Your objective is to write a program capable of predicting the route Indy will take on his way down a tunnel. Route or route? Never know how to say that in English. Anyways, Indy is not in danger of getting trapped in this first mission. Okay. The tunnel consists of a patchwork of square rooms of different types. The rooms can be accessed and activated by computer using an ancient RS-232 serial port, because Mayans aren't very technologically advanced, as is to be expected. There is a total of 14 room types, 6 base shapes extended to 14 through rotations. Upon entering a room, depending on the type of the room and Indy's entrance point, top, left, or right, he will either exit the room through a specific exit point, suffer a lethal collision, or lose momentum and get stuck. And here are the, how many? 14? 6, 1, 2, 3, 5, 6, and these would be the rotations, I guess. 1, 2, 3, 4, 5, and 6. Right. And these are rotations of 5 and 6. Oh no, these are rotations too. Hold on. These are the same. Well, whatever. Let's figure it out as we go. So this room type is not part of the tunnel per se, as Indy cannot move across it. The green arrow indicates Indy's possible paths through the room. Type 3 rooms are similar to Type 2 rooms, but rotated. A red arrow indicates a path that Indy cannot use to move across the room. Obviously. Right. I think I understand. Okay, so you can't come from here, but you can go to there. That's interesting. Okay. Indy is perpetually drawn downwards. He cannot leave a room through the top. Oh, okay, and that's why. I get it. So that's why you can't go up. Can also can't come from here because that would mean going up. Same thing here. Gotcha. Yeah. Okay. At the start of the game, you are given the map of the tunnel in the form of a rectangular grid of rooms. Each room is represented by its type. For this first mission, you will familiarize yourself with the tunnel system. The rooms have all been arranged in such a way that Indy will have a safe, continuous route between his starting point, top of the temple, and the exit area, bottom of the temple. Each game turn, you receive Indy's current position. Then you specify what Indy's position will be next turn. Indy will then move from the current room to the next according to the shape of the current room. And so we could be coming from here. We could be, okay. Indy reaches the exit. You assert an incorrect position for Indy. Okay, yeah, so here's an example. Indy starts in the room 1, 0. Can only go downwards, so that would be this room type here, type 3. 1, 0 can only go down, then he would go left. Okay, so basically there's no choices to be made here. Are there ever choices to be made? I guess there would be. If we're looking at, I don't know. We'll figure it out. The program must first read the initialization data from standard input, which is what we're seeing, the boilerplate stuff here. Then within an infinite loop, read the data from the standard input related to the current position of Indy and provide to the standard output the expected data. Line 1, 2 spaces separated integers, width and height, specifying the width and height of the grid. Next, H lines. Each line represents a line in the grid and contains W space, separated integers, T. Space separated integers, okay. T specifies the type of the room. Cool. One integer EX, that's the last line, specifying the coordinate along the x-axis of the exit. This data is not useful for this first mission. It will be useful for the second level of this puzzle. So line 1, xi, yi, pause. 2 integers to indicate Indy's current position on the grid. Pause to a single word indicating Indy's entrance point into the current room. Top. If Indy enters from above, left if Indy enters from the left, and right if Indy enters from the right. Right, okay. A single line with 2 integers. That's what we are output for one game. A single Oh no, wait. What are we supposed to give? Read the data from the standard input related to the, and provide the standard output to the expected data. And we're expected to, we're expected to output this, I guess. A single line with two integers representing the XY coordinates of the room in which you believe ND will be on the next turn. Okay. And what are our constraints? The width won't be bigger than 20. Same with the height. T is the room types. And XI is the current position on the grid. XY is the position that we, yeah, okay. Response time for one game, 150 milliseconds. Oh, more examples, okay. So we're getting this as input. And 2 of width, 4 of height, so 2 by 4. 4, 3 would be, what's 4, 3 on the next line? The starting position, I'm guessing, in these. Oh no, that's all the room types, right? No, hold on. We're getting the next H lines, each line represents a line in the grid and contains W spaces separated by, yeah, okay, so that's right. So these are the two first types, type 4 and 3, which would be this here and this there. Is that right? Yeah, okay. 12, 10, 11, 5, blah, 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 blah. EX is 1, and I'm guessing that's the exit point. Input for one turn. We're getting 1, 0 top. So we're beginning at 1, 0. Determine that ND will be in room 1, 1 on the next turn. That's correct. We're starting at 1, 0 from the top. Then it's going to be in room 1, 1. Determine that ND will be, okay. Then we're getting 1, 1. Got there from the top. And we're saying, okay, he'll be in 0, 1 the next turn. Cool. Okay. Andy, the greatest adventurer of modern times, except maybe Lara, finds himself once again in a sticky situation. During his exploration of a Mayan temple, at the very moment he grabbed a relic of the feathered serpent Quetzalcoatl, a concealed hatch opened up beneath his feet, plunging him at high speed deep into a dark underground tunnel, and leaves at risk of slamming into a wall or getting permanently stuck on the ground at any moment. Luckily, you, his loyal assistant, are here to get him out of trouble. Okay, I think we're about ready to start coding. I have an idea, reading through this, of what they're expecting us to do. So we're obviously going to need a 2D array for the actual tunnel system. And the map, associative array, hash, whatever you want to call it, is going to be used to store the different room types and their associated directions, basically. So room type 1, coming in from a certain direction will output another direction, something like that. So we'll have to figure that out. But I think a map will do nicely here. Okay. So I'm going to set this up for my external IDE. Change the local file name. I already set this part up. What's this thing called again? The Last Crusade. Last Crusade. There you go. Last Crusade. Okay, upload from, actually, let me first, did I copy this in there already? I did, okay. So upload from file, and we're in business, okay. And I want to target ES6. Make sure I've got ES6 library in here too. ES 2015, technically. Okay. Let's add a file that we're going to call. What do we need to do here? We need a function that predicts Indy's position. So predict Indy pause.ts. And we'll make a test file as well. Predict Indy pause.test.ts. Describe. We're going to be testing the Last Crusade. Episode 1. Okay. Which makes me think that I have to... What would happen if I try running the test right now? I think I gotta... Yeah. Ooh, we're failing a test. This one, okay, good. What was I working on last? Closest number. I need to just X out the tests here. I only want to run my Last Crusade tests. So now, if I run the tests, good. Okay. Test. Let's see. We're going to be using coding games first. Test case. Oh, we don't have access to them? No. Why? You sound no happy. If I do that, what would happen? It's just a straight through tunnel maybe, or oh no, it's just, oh, that's too bad. I don't know why some of them have test cases and others don't. We're gonna have to make our own, but that's gonna be complicated. All right, okay. Let's export function. What did we decide we were calling this thing again? We were calling it predict. Yeah, predict Indy pause. Now that function is going to be fed. What are we getting every turn? We're getting this information here. Indy's current position and the entrance point into the current room. So we'll call this current X. Actually, we'll make it a Y first, because in 2D arrays, the Y comes before the X usually. The height is first, and then the lines. Current Y, current X, and entry point. These will all be strings. Although, yeah, okay, let's just make it a string. We'll convert it to whatever we need in here if need be. And now we're expected to output. We're expected to output a single line with two integers, X and y. So let's just do string. Just have to make sure it's formatted properly. Okay, so where do we begin? We're getting a current y, we're getting a current x. We know which position he's coming from into. Wait, hold on. What is the current point again? A single word indicating Indy's entrance point into the current room. Right. And that is important because let's say this is a room, for instance, type 4. If he'd be coming from the top, he would end up be going left. If he'd be coming from the left, he'd end up being going down. Okay. And I guess that's the whole thing we need to do. I need to have some kind of a map. So we've got, let's say, type 1. And then I need to be able to say, okay, for type 1, he's coming in from top, let's say. And then cool. And that just returns the direction he's going to be going next. Right? That makes sense. So in the end, what we need is a map. A map that has, well, we can make it have whatever we want. It could just be like type. I could make an enum with all the types, with all the map types. Now I'm guessing since we're dealing with like rotations and stuff like that, hold on. Since these are basically, well, they're similar, right? Like they go through the trouble of saying that we have 6 base types. Where did it put that? There's a total of 14 rooms, 6 bases, 6 base shapes extended to 14 through rotations. Now, does that mean that we could just have like a map of 6 base types and use some sort of a, I don't know. I think I would prefer to, anyways, starting off, I think I'll just do the 13. Well, oh, and actually here, yeah, that's it. There you go. That's interesting, right? They go through the trouble of giving us a type 0. So that's a strong indication that we're expected to use some kind of a zero-based index system, like an array, for instance. And that's what we're getting right when we're setting up. When we are setting up the whole grid thing. So I'm going to need more than this function. This function just gives me current y, current x, entry point. This is going to need to have access to our grid, because we need to, we're storing the types somewhere. So let's say our grid is our grid is going to be a 2D array 2D, array 2D. Let's import that. No? Isn't that what I called this thing? Yep. interesting. Why doesn't it give me the... Alright, so let's just do it ourselves. Import array through 2D from its to go down one level to another level. Helpers array 2D. There you go. Okay. So we need to make an array 2D. That's probably going to be something that we're going to need to... Let's see, let's take a look at what we're getting here. This is where this needs to happen. No, actually that's the game loop, so here. Here is where this needs to happen. Okay. What do we have in that line? Simply have so we'd be calling something like function. You know what? I think I'm going to make this whole thing a I could make it a class, I guess. Let's not. Let's not. If I can avoid it. So it would be something like make grid. Let's call it that. And you'd pass in the W, nope, the H first. Then you'd pass in the W, and then you'd pass in the, oops, it'd have to be X. We'd have to, okay, let's call this add line, maybe. And then we pass in the line. That sound about right. So then we'd have something here called function add line current y, well, let's just call it y, x, line. This will be a string. They're all going to be strings. Yeah. That's the kind of input. Actually, the x and y's might be numbers here. Yeah, parse int, so they're numbers. Okay. And we're not returning anything. This is just a side effect. So let's say we do const grid equals new array 2D. Let's just leave it empty for now. Now if we do grid dot, what do I have in here? Do I have an add? I guess it would just be a push, right? Yeah. It would just be a push. We're just pushing the line, but what are we pushing exactly? Technically, I guess technically we don't even need those. Oh, do we? Because we're taking in an entire line here. I could just push whatever I need straight as an array. Yeah. Let's see what I can do with this. Grid dot push, and that would expect an array. And then I would just need to split. That's right, I would just need to split the line, basically. Just need to split the line into an array. I split it on empty spaces. Right, I think so. So it's done. Let's go at line to grid. To grid. Need to import this. Okay, so let's first see if we're getting the correct representation of our maze, if this is working properly. It should. But let's just make sure. So we're going to test this right here. Once we're done parsing all that stuff, console.log grid. I don't really want this to be, well, I guess I'll just export it for test purposes. Okay, and then we'll just run that straight in code and games, see what, oh, hold on, did I, yeah, it's the grid itself. See what happens. Oh, I should have, that line to grid is not defined. It's not? Really? Seems defined here. I'll make this an error. Add line to grid. Add line to grid. And it's saying add line to grid is not defined. Answer on line 12. Oh. Am I not? Okay, unexpected token. Note to import files that are not JavaScript. What are you talking about? Let's reload that. Huh. Well, that's interesting. Error unexpected token. Note that you need plugins to import files that are not JavaScript. Yeah, and I do have something. Right, got plugins TypeScript here. What are you going on about? Oh, it might be treating it as, okay. Wait a second. UMD. It's failing at the UMD part. I don't know why it would. Unexpected token that you need to plug in. Got it right here, dude. Got my TypeScript plugin right there. What is this thing called? Very 2D. .ts, it's just a normal TypeScript file. Oh. Let's remove that for now. Not that I think it'll change anything. That has nothing to do with it. Is it the fact that I'm importing it here? That's no, that has nothing to do with it, but let's see. No. Odd, super odd. And what if I was gonna, let's see. Let's say I've said forget about the UMD. Let's just do the node stuff. Don't really care about UMD anyways. Same problem. Default imported from external module. Roll up plugin no resolve but never used. Unused external imports. Bundles, series on Last Crusade, distance. Unexpected token, no that you need. Okay, I think because this is in a different folder, it's not treating it as an internal module. And I would have to enter it here, maybe? This is where you would include external CommonJS modules. Okay. That's a pain if that's what we need to do, but let's see. Never had to deal with this before. So roll up external modules. Tree shaking, blah, blah, blah. Export default can be an array for multiple inputs. Config. No. What the heck? I don't want to read this. Jeez. Named imports. Using plugins. Code splitting. Blah, blah, blah. What was it called again? External. Let's just do a search for external on that page, because external, oh boy. Big list of options. Wow. This is bullshit. Okay, you know what? Forget it then. That's how you wanna be. I don't feel like figuring it out, so we're just gonna do, how are we gonna do this? Well, I guess I could try putting something in there just for, and it would be like that. Ugh, I don't get the, so we're going back one up, which would take us to Last Crusade. No, we're in Last Crusade, so all we need to do is helpers, and then array 2D. Not a common JS module though, it's just a straight TypeScript file, so I guess I would have to kind of make this into a, ugh, what crap, that's not gonna work. Why can't I just import this in there? Why? Why? I commend you to work. Boom. Don't want to fool around with this right now, so here's the solution. Of course, it's not something I'm going to want to have to do every time. But for now, just so that we can keep going with this puzzle and not try to solve another one, which is why can't I import this? I will look into this though later. So now we're going to import it from, which would explain why IntelliSense wasn't finding it before, but whatever. Okay, array 2D, there we go. There's something I might not be quite understanding with how imports work and modules and packages and whatever. But now this should work. npm, I guess we could uncomment this out. Not that we really care about having a UMD bundle, but whatever. npm run dev. Now that works. And we should be getting something here. Okay, good. So here's what we have. We have a 3D array. Oh, but the thing though is I don't know what the inputs are. How am I even supposed to know if this is correct? Just have to kind of, okay. But it looks like it's just one straight tunnel, one straight down. Type 3 would be just the type going, yeah. So the first one is simple. Excuse me. Okay. So we now have a grid that has as its value the type of each room. Now what we need is a table, a map, whatever you want to call it, where we can just look up the type, give it the direction we're coming from, and it'll tell us where we're going. Does that make sense? Makes sense to me. So that's what we're going to do. We're going to make a... Let's see, can we do this using a little bit of... Is there some sort of logic to... I mean, I could just... Okay, I'll just hard code it. It's not that long. And if I can think of a way of just maybe using some sort of clever generating algorithm, we'll do that. But for now, let's just do const map. I don't know what we could call this, but well, we could call it room types. How's that? Room types is going to be a map, a new map. The keys will be a number. Wondering if I should use... Would it make sense to use some sort of enum here? Would we get any benefit out of it? Not really. So, okay, and now here's the thing. We need some sort of object, right, that would look something like the top. What are possible directions? We're going to be coming in from the top. Yeah, we can be coming in from the top. We can be coming in from the... What are they? I think they're supposed to give it to the top, left, and right. Yeah. So... And they are, I think, capitalized. So we'll just top, and then left, and then right. This is all kind of just pseudocode what I'm doing here. So right, so and then what? And then what? Depending on the type, we would have a direction. It would output a direction. It would output a direction. The direction we would want actually I can do even better than that. Let's think about this here. I could make it that it just simply outputs. Let me think about this here. So what I would do is I've got my grid. So the thing is I would need to, okay, this would be happening here, right? So I would do grid. Let's simply dot get. Then the height index I'm getting from my function here. So that would be current y. And then this would be current x. And then current y of type string. That's right. Need U to be a number. So how's that? Boom. Now I'm going to call this const room. Right? Okay, we've got our room. And then with the room, what do we do with that room? We are going to do something like room and then entry point. And then what are we going to get from that? Well, that depends. What are we looking to output? We're looking to output the next room we'll be in. We're looking to output the next room we'll be in. So would it make sense to actually have this return a function, and in that function we just have to pass the current y, the current x, the current y, and the current x. And it would give us the next room. It would return the room. So what would that look like? It would be something like this. Now if top, so if we know that this is, let's say, object of type, and we know that's the only type we have here, of type 3, which is, let me just bring that here, all right? Type 3 is just straight down, boom. So we know that it's only possible to come in from the top for this object. So let's type it. Let's type it. Object type 1. And I'm starting to wonder if we need to store that in a map or just anyways, one step at a time. So okay, top, and then we return a function that would give us the current y. Oh, let's just call this y and x. And then you do what? You take the grid and you go move, no, get, move, get, okay, get and south. That's the only, this type can only go south from here. There you go. X, boom. Yeah, just give us numbers, please. For this one anyways. Room is of type unknown. Yeah, I haven't set that up yet. So that's, I think, that would work. So now it's a matter though of either I'm making a map out of, yep, let's see. Well, I could just use an array. Don't really need a map. I can just use a straight up array. Yeah, okay, so I would, oh no, I can't, yeah, I can, yeah, I can, this is an object, so if I do const room types equals an array, not an object, an array, and then the first element, which is, index 0, needs to be an object. That object has that property, and move on to the next. That work? Oh, it would work, but I'm wondering if there's a better way to do this, right? So for starters, it's kind of hard to see what is what here. What's the index of each room type, I am tempted to... Is there another way to do this? Really? Room returns that's not quite right, is it? Grid.get I should say that this is of type number. That would help us. Right, so now we've got our room number. And now with our room number, why am I saying room like this? That's not right. What I have to do is room types, and then actually access room types, room. So let's call this room type. And then go into the room types array, look up for the room, then the direction, entry, point, and then of type string cannot be what? Element implicitly has any type because expression of type string can't be used to index type. Oh yeah, I would have to do this. How does this work again? I would have to type this. So you're expecting this is an array of objects that have a key of type string. How does this work again? Keep forgetting how to type these things. Key of type string. This needs to be, oh yeah, this needs to be like this, I think. Key of type string. And values of type function. What's it returning? It's returning it's returning the next function type, but that's, oh crap, that's not what we need. Is it now? If I use this, it's great and all. It's going to get me So that one works. mark. Well, well, well. Huh. What if we do... So we need to return, what are we going to need here? We're going to need a string. So we would need to return something like this. If I... And it would need to be... Which one? Whoops. Just get that for you guys. We need to return output, 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 X and Y, okay. X and Y, but X is what? Oh, well, that's confusing. Oh, okay. X is this, Y is this, okay. All right. So we'd be returning if we're coming in from the top, it means we're going down, we're keeping the same X, but we're getting a Y that is one bigger. Can't believe I need to do this here. That's precisely why I made this nice little array 2D thing, so I wouldn't have to hard code these kind of things. But now it turns out that this puzzle wants me to do it that way. Okay. Like instead of returning the type of the next room, I have to return the coordinates of the next room. So, which I didn't think, you know, I should probably put that in there. There might be some other puzzles that require this. So. And then instead of doing this here, I could hard code. Yeah, I could do that. Instead of hard coding these, I could make a... Should I make this an enum or... Yeah, you can't make an enum be a property, a field of a class, I don't think so. But I could do this, let's see, just a bunch of static fields. So like static north. And this would be hard-coded, or not hard-coded, but it'll be like it would be like static read-only, let's say. Private, no, it could be useful to access it from the outside, which is what. So static read-only north, and that would be what? So if I change the signature from I could overload get and have it so that you can either pass let's think about this here. North could be an array. What would make sense here? What are we trying to get here? We're trying to get x plus 1 there. I don't think there's a way to do this. I'm going to need a reference to this stuff here. Hmm. Okay. I feel like I'm doing too many things at a time here. We'll get back to this idea later. Let's just solve it first and then see if there's a way to refactor this better. So for now, this is what I need. Top. So you give me the room types. Give me the room type. 0. Tell me what direction you're coming from. Top. And then I'm going to tell you that actually top, then give me the current y, the current x, and I'll give you the next room, which is this here. Oh, it seems to be the problem. Oh yeah, I was in the middle of typing this thing. So returning a string. Not happy with that. Type top. String is not assignable to type. String. What? I'm obviously doing this wrong. Could this be the proper syntax? No. No, I think I had that right. Shouldn't have a comma here though. Ah! Right, that's the object we want to return from the array. Top is not assignable to type string. Correct. We didn't put the so y number, x number, and now we're good. Okay. TypeScript should be satisfied with what's going on with this. It is confused, but whatever. Syntax is right. So technically for this test case, that's all we really need. Then it would be a matter of, oh, why, what's going on here now? Why is it complaining? Argument of type string array is not assignable to parameter of type number array. Type string is not assignable to type number. That's a good point. That's a good point there, buddy. Because we did say these would be numbers, but they are in fact strings. Okay. And now what? Room types are of type strings and undefined, so then I would just need to do this. Room, cannot find name room. Room type. Room type. Object is possibly undefined. It's a good point. I mean, if something technically and if I try to access an array with an undefined index, it's probably going to blow up in my face anyways, right? I'll hear about it, won't I? It doesn't matter though, because TypeScript won't let me do so. If there's no room type, please throw some kind of exception. So let's throw a new error that we will call No room type. No room type. Biatch. No. No room type. Or invalid room type would probably. Well, actually, it's not the room type that would be the problem. It's these position invalid positions. Yeah, invalid position. Grid position. There you go. Invalid grid position. Okay. Now, we've got our room type. We've got our entry point. Now, what's wrong with this? Oh yeah, we need to pass in numbers. Okay. And now we're being returned. What are we returning? It should be that string. It should be that string here. Right. Just put that in there. Reminder. So let's try this then. I think we've got the skeleton of what we need for the entire thing, but let's see where I go wrong. Never works the first time. Well, sometimes it does, but so this is that, and then basically just need to predict indie pause. Predict indie pause, feed in yi, xi, and then pause. Now what argument? Oh, they do change them to numbers for us here. So good. I'll simplify things a little bit. And then that means I can actually store a number here. No, it's still going to be a string. That's a string from up there, right? Read line, yep. Okay. But this here we're getting as inputs 2. That's good. No type errors. This is good. All right, let's try this. Let's give it a shot and see what happens. Cannot read property top of undefined. Let's see here. Don't need you. Don't need you. Don't really need this. I might need this later though. Let's get that here. And let me run this again. And he enters the tunnel in cell 10, entering from the top. Boom. Cannot read property top of undefined. On line 61, return room types plus room type entry point. So entry point is the one that doesn't work. Ah, right, because the room type, oh, and here's the problem. Ha. Herein lies the problem. This is in room type 0. This is room type 3, I think. Room type. Where did I skip this? Oh, yeah, it's room type 3. So this needs to be in index 3. So for now, I could just do this. I think the cheater I am. So 0. Boom. Nope. Boom. And then 1. Boom. and then 2, and boom, and then 3. Room types. Yeah, this is going to be annoying. Huh. What if I was using an enum for this? Would that be so horrible? It's not really what you're supposed to do, I guess. No. I mean, a map is a really good way to do this. Oh yeah, okay. I know. Because if I make it a map, let's see. Let me just comment that out. I think you can, yeah. Okay, so let's just do this. Room types, and then just do equals new map, and I think you can, yeah, I'm pretty sure that maps you can see, yeah, that's right. And then just a set of key value pairs. So key of 0, or actually we only care about key of 3 right now, and value of this object here, which is going to get really bloated though. But, you know, we gotta do what we gotta do. And what's wrong now? Oh, right. It needs to be, this needs to be its own array here. Yeah. I don't know that that's the best way to, okay. That's how Prettier does it. It's not bad, actually. And it gets the type number and then some sort of, it'll complain though as I add some, maybe. We'll worry about that later. So now we need to access this a little differently. We're gonna get get 3. That's our key. And then that's going to be some kind of an object. Element implicitly as any type, because expression of type string can't be used to index type. Oh, I gotta do the index thing. Yeah, shouldn't have deleted the other one. Okay, let's do this. So number, we know, and then we're expecting objects that have an index type of string and that return this kind of function, which I really ought to, well, maybe string like that. Okay, now what? Object is possibly undefined. No. Why? All right, well, what if it's not in there? Right, it returns undefined. That would be horrible. Room type. And so what if it's undefined? What's going to happen? It's just going to try to access something of undefined, and then it's going to... Okay, let's split this up. And we're going to call this const. What are we going to call this? Room. That's the actual room, I guess you could say. Whatever. For now, anyways, it'll work. Just that. And then it's... Oh. Now what? Room is declared, but its value is never read. Yes, and room type. Argument of type strings, not assignable to type number. Okay, so there, type number. Now what? Object possibly undefined. Yes. Okay. That's what we're dealing with here. So if there's no room, throw error. Really shouldn't get to that though. Invalid room type. I don't see how we could get to that, but we'll guard against it, I guess. Then return room entry point. There we go. Okay. I think we're good. Let's take a look here, see what happens. Yep, we got it. We got it. Yay. Falling, 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 falling. Whoops. How does this work? You win. Doesn't seem like I'm winning. Okay. Should we refactor? Not at this point. Let's just try another one. Sewer. Okay, play test case. Oh no, invalid room type. Well, we know that because we've got... Okay, actually, let's try to figure out what our room types are. Okay, it's a little bigger. It's a wide maze. We've got 3. It's good. We already have that one. 11, 2, and 13. And 10. So let me just write that down. So we've got 2, 11, 12, and 13, and 10, and 10. 2, 10, 11, 12, and 13. I don't see any other new ones there. So let's see how painful it's going to be to add these. So let's first get 2 in there. Index 2. What does 2 look like? 2 is just sideways. You can come in from the left, you can come in from the right. So you would need left and right. Let's just copy this here for now. Okay, what's it complaining about now? Argument of type number, left, Blah, blah, blah is not assignable. It's a parameter of type read only. Blah, 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 blah. Right. Silly moi. My bad. Let's get out of here. And instead do this. And that. And this. And that. There we go. So that's done. Oh, that's interesting. What the heck did it just do? Oh, it's splitting that thing up. That's prettier at work. Prettier really doesn't want us to go over that 80 character per line rule thing. But this is unreadable, so let's make this the type. Well, let's call it, let's see, type direction function, direction func. Direction func. That should work, right? Oh, actually, it's not just a function, it's the whole object thing. So type of room. That's what we're going to do. Then room. And then please bring that back up there. Yeah, thank you. Good. And now, we need one for, sorry. So if you're coming in from the left, so for both of these, we're staying on the same Y. But we are, if you're coming in from the left, you're going to go to the right. So +1. And the opposite for this one. -1. Simple as that. We're done with 2. Now we need one for 10. Why'd you go and shove that in there? Okay. And type 10. Hey, what happened to my music? I don't hear much. Doesn't seem to be playing. Interesting. There we go. All right. So type 10. You can only come from the top. technically. Anyways. Can only come from the top and exit to the left. So top is the only valid one. Get rid of this one. And we would be going to the left. Like that. Now we also need 11. 11 is basically the opposite. Go to the right. So easy enough. Okay, so as I'm going through this, is there an easier way to make our map? That's what I'm wondering. Well, this here is really simple. What I've got going on is really simple. Why don't I make this even simpler and just call this simply Y, and this simply X. Oops, what am I doing? Okay, X. Tell me that's even too long. Oops. Okay, let's just call this entry then. Entry. That in here. There we go. XY entry. Just want to make sure I didn't break anything. Run that other one here. We're good. Okay. So we were adding 11 is done. 12. Come in from the left, go down. So you come in from the left. And the only thing you can do is go down. Which means y plus 1. You would never get a y plus y minus 1 because you can't go back up. Okay, and then 13 is going to be coming from the right. No, I got this wrong, sir. You're coming in from the right on this one. Anyways, I've got them inverted, so let's just fix that. So this will actually be fine. This should be right. Right. Coming in from the left, go right. Coming in from the right, go left. Top, blah, 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 right. Cha-cha-cha-cha-cha. So looking at this, technically, this should work. It does. Okay, well, so far it's really not that complicated in terms of algorithms. Let's try the next one. Secret pathways. So what do we need here? I can see 8. 8 we didn't have before. 8. And then 1. 1 we didn't have before. 4 as well. 4. So 1, 4, 8 are the new ones we need to implement. 7 as well. 7. 5. So 1, 4, 5, 7, and 8. I don't think I missed any. We already have 3, 12, 11, 10. Okay, let's do it. So first of all, type 1. Oh, there's type 0 too, but I guess we don't really care. We don't really care for now, anyways. So type 1. Type 1, you get to come in from the left, from the right, and from the top. And from the top. If you're coming in, they're all going down, I think, for type 1. They're all going down. All 3 of them are the same. Ah! Okay, so here's... I'm beginning to... Well, this is definitely duplication here. This is definitely duplication. So let's have const directions. Turn that off. If I can. Okay. Go. Sorry about that. Okay, so directions, directions. Sure, let's just call it that for now anyways. And it's going to have, if we're going down, this is going to be, if we're going down, if we're going down, if we're going down, this is one, okay. Just this, like that. And if we're going to the left, using a comma, going to the left, then it's going to be, well, let's just, oh, there. If we're going to the left, we are, this is the one, right here. If we're going to the right, this would be the one right here. It's pretty much our only 3 directions we can move in at the moment anyways. So let's replace that with this one. We're going down for directions dot down. Boom. And all of those we're going down. Okay. There we go. If we're looking at this one, what are we doing here? We're going right. We're going right. So directions dot right. And here we're going left. So directions dot left. And here we're going down. Directions dot down. And here we are going left. Left. And here we're going right. And here we're going right. No, that's not right. What was it? We're going down. Yeah, okay. Directions dot down. Hope I didn't screw this up. And this one we're going down as well. Most of them are going down. So I don't know. Okay. I think I'm getting some ideas here. A little too early for me to see if it would work, but okay. Good thing we didn't screw this up. We didn't screw that one up either, so okay. We can keep going with this. So we had implemented 1, now we need to implement 4. 4, we've got 2 possibilities. We can come in from the top and we can come in from the right. So top and right for 4. This, that, 4. We can come in from the top, and if we do come in from the top, let's see, let's just put that in first, right. Okay. So if we're coming in from the top, we are going left. Otherwise, we're going down. So top, left. And this one would be down. Okay. So that's 4. Now we need to do 7. And 7 is going to be, can either come in from the top or the right, but both of them are going down. So from the top or the right, but both of them are going down. Okay, and 8. Type 8. Type 8, what are we dealing with here? Can come in from the left or the right, but you're going down. So from the left or the right, in both cases, going down. So let's run this. And it works, okay. On to the next one. Labyrinth. Okay, this is a lot more complex. We're probably missing some types here. 6, I see a 6. So we need 6. A 9, I don't think we have. 4, we got it. 3, we got it. 8, no, we got 8, we're good. 5, we've got it. I think those are the, well, at this point we might as well go ahead and implement all of them. There's not that many left. 1, 2, 3, 4. Oh wait, I thought I had 5. I guess not. So 5 as well. So 5, 6. We need to do 9. I think those are the only ones missing, yeah. Okay, so let's start with 5. Five is going to be coming in from the top or the left. Top or the left. Top is going right, left is going down. Top is going right. Top is going right. The left is going down, okay? And 6. 6. 6, 6, 6, 6, 6. What am I doing here? 6 is, as far as we know, coming in from the left or right and going to the opposite. So 6 is kind of like this one right here. It will be different in the next puzzle, but for now that's all we need. And the only one we're missing is 9. And 9 coming in from the top or the left, both going down. Top or left, both of them going down. Okay, let's run this. It's working. Look at that. Woo, yay. Woo. Exciting stuff. Yay. Woo. Let's put this full screen. Yeah. Woo. We win. Okay. And Mausoleum. This also works. Let's look at this. Boom. Boo. Yay. Yay. But it's kind of weird because there's no choices to be made. Like we don't get to choose which. There's no pathfinding. There's no. But I guess maybe in the next episode, it's going to be some of that stuff going on. But that was. I mean, they've got this as a medium, but I find this was really easy. As like the algorithm is really easy. Now, the challenge, I think, is to try to figure out if there would be a way to have this room types map generated in another way. This takes a whole lot of room. While we could code, let's see here. We could use like a bunch of enums. Oh yeah, that could be interesting. We could use a bunch of enums for the directions. That still doesn't prevent, I mean, it still doesn't, we still need to kind of hard code that stuff in at some point. Is there like some kind of pattern that I'm not seeing here where we could just like kind of generate this with a loop or something? Or 13 is left, down, right, down. So okay, so both of these, I gotta plug this in. Both of these are going down. There's a bunch of them that all they do is go down, right? Most of them, they just go, well, yeah. Most of them just go down. Well, anyways, what we're gonna do is probably just, for now anyways, until we figure out a brilliant way to represent this differently. I'm gonna make a new file that we're going to call room types. Room types. .ts. Move that in there. All of this, actually, all of that. Boom. Do I need this somewhere else? Am I using these somewhere else? No, I'm not. The grid, though, I am. So the grid will stay here.
2, 1, 2, 1, 2, 1, 2.
Let's get this out
1, 2,
into room types.
2, 1, 2, 3, 4.
We need this in here. Okay. No syntax errors here. No syntax errors. Oh yeah, okay. So as I was saying, there is a possibility to use enums. So instead of having one and then this big object here, if I use enums, I could do this could be an array, and then the value would be simply so if I know that so if I'm using enums for left, right, and top, then you know the index in the array would be, oh, that still doesn't work though. No. Nope. Although it could be a map. Oh yeah, that could be if I'm using a map of directions. If I have a convention that left is 0, top is 1, and right is 2. No. I don't know. I'm sure there's a way to make this like smaller, but I can't think about it right now.
1, 2, 3, 4.
So I'm not going to worry about it. We did what we had to do. This works. I'm going to use the map here. Yep. Satisfied. Satisfied with this. This is what we're going to use. So let's say, just make sure that it works. Oh. Oh yeah, I'm gonna get rid of this here. Boom. Okay, let's just make sure this all runs properly, no errors. It all passes. And we'll submit. It's computing our score. And we win. Achievement unlocked. Yay. So what are we rating this? I'm gonna say just okay. It wasn't that interesting. And I'm curious. Let's see. We've got a few minutes left. Let's see what everybody else is doing here. 00 Steph. Let's see what you did. Yeah, it's pretty much exactly what I did. He's just got it like as an array. I used a map, so I thought I was better than, but that's one way to do it, I guess. Takes less room, but that's exactly what I did. This is just a bunch of unreadable crap. Shouldn't say that. It's just this guy was clearly not going for readability, but just for what is he doing though? Ah, my head hurts just looking at that. Let's see if somebody else tried something. Yeah. Okay. Yeah, used an array here too. So far no one's using maps. But see, they all need to add comments next to it. Right, so I thought using the map and actually setting the key to 0, 1, 2, 3 was more expressive. But and game loop while read line parson. Yeah, they just shoved it inside the loop there. So yeah, you're getting this types. Wait, this guy doesn't have, what's this B? B, R, L. Where are those? Oh, here. Oh, okay, he's actually typing it like C. And then Y plus plus, Y. Okay, yeah, that's smart. I like that. Why change it if you don't have to? Yeah, okay. It's a nice little solution. I like it. Upvote. Okay, this guy's interesting. He went the other way. Tubes. Cool. Very nice. Very nice. Type 4 cannot be entered from left. This guy's throwing exceptions. Alright, anyways. That's interesting stuff. Next step. Guess we'll keep going with maybe next episode of this puzzle on the next episode of my show, which doesn't really have a name, but anyways. Okay, so that's it for me. It's been about 2 hours. Got to solve this puzzle, so that was fun. And I'll be on, we're Friday, so I'll be on next Monday, 9 a.m. Eastern. Take care, guys.